Okay, sorry about that, but I did warn you that that was gonna happen. So now we should be moving pretty quickly because, we've already talked about the main stuff. That just takes a while to understand. Once we start doing a lot of examples, they'll go by a lot faster, I'm hoping. Anywho, so again, just keep in mind that if you were in class, you know, your class period is generally 50 minutes. And I usually have to do this in a 2-class period setting. So just keep that in mind, as I know this is long, but I just wanted you to be able to have somewhere to look for the information. So anyway, so here we go, negative cosine x. Good news, here's our amplitude, is the absolute value of negative 1, which is still 1. So we're still going to oscillate between 1 and negative 1. My period here is still 2 pi because there's no b value. So I'm going to go all the way to 4 pi like I did in the last one. Only this time I don't have to do any weird shifting up or down. So I'm just going to go pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. So I have all that. The only thing that's different now is that you have this negative, all right? But that's not too difficult. Well, all that means that it's going to invert all of your values. So for example, normally when I would plug in a 0 to cosine, I would get positive 1. But because there's a negative in front of that, it's going to make that a negative 1. So in this case, instead of your cosine curve starting at its max, it's going to be starting at its min. So all that really means is that if you go back to this guy, instead of going max 0, min 0, max, it's going to go min 0, max 0, min. So that's the only difference. So we're going to go ahead and do that. So you'd be at your minimum instead of your maximum, and then you'd be at 0, and then you'd be at the maximum, then you'd be at 0 again, then you'd be back at your minimum. I hope that's not too, okay? And then that would be one cycle, and then you do it again. So back to 0, now back at your max, back to 0, back at your min. So now you're starting and ending at your min instead of starting and ending on your max, just because of that negative. So that then becomes your graph. Alrighty? So that is part B. So now I'm going to go to example 2. Which is this guy, I believe. And we're going to, now you see you have a different amplitude. You still have the negative, so that should be familiar to us. You still have the negative, but now your amplitude is 3, because remember the amplitude is the absolute value of negative 3, which in this case is 3. What that tells us is that instead of going above and below by 1 unit, we have to go above and below by 3 units. So we're going to make our little t-axis. So far, nothing too complicated. We don't have a horizontal shift this time. There's no like x minus c. There's no plus d. All we have to worry about is this change in the amplitude. So because of that, we're still starting at 0. We don't start anywhere but 0 unless there is a phase shift, which is that c value I was talking about. So now we're going to say we're starting at the middle here, and so 3 above that would be 1, 2, 3, and 3 below that 1, 2, 3. So you'd be at negative 3 there. And then we're going to do our x-axis, which again we're going to start at 0 and go all the way to 4 pi because we're doing 2 periods. Go somewhere in the middle here, call that 2 pi, and then we're here, here, and here. So we've got pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, and then 8 pi over 2. So all of that is good to go. So now we're going to graph the actual curve. Remember, cosine starts at its max, but because this is negative, we're actually going to start at the min, but then otherwise it's the same as the previous one. Then go back to 0, go back to the max, which is now 3, go back to 0, go back to your min, do it again. And then we connect our curve. And there you go. That would represent your -3 cosine x. So it's basically upside down, and there's no phase shift, no. So there we go. Okay? So now we want to go to example 3. So example 3 is going to be when we throw that away, and then come over here. Example 3. In example 3, now we're starting to see that there's B values here. So these ones have some B values and some A values and some negative. Now we're doing a sine curve. That's kind of cool. We haven't done a sine curve yet. So let's go through and talk about that for a second. So now what's going to happen is you're going to have your amplitude is still going to be the absolute value of 4 in this case, which was just before. So that tells me that I'm going to bounce between 4 and -4 because there is no D value. Remember that the D value is what would make us go up or down from our middle. But we're going to stick with 4 up and 4 below. And then this little guy is going to affect our period. So the formula for period is 2 pi divided by B. I'll remind you that it's 2 pi divided by B. And in this case, B is 3. So my period is 2 pi over 3. And so that's going to affect where we start and end. So I will explain that in a second. So as I come over here, I'm going to draw my axes here. There's no phase shift, so there's no C value. There's a B value, but there's no C value. So that means that we're still going to start at 0 on the x-axis. And on the y-axis, I have to go all the way to 4. So we're going to go maybe 1, 2, 3, 4. And then we're going to go down 1, 2, 3, 4. That's to accommodate our amplitude of 4. But then now I'm still going to go clear over here, but my period is 2 pi over 3. So instead of completing one cycle at 2 pi and 4 pi, my period is now 2 pi over 3, which means that it's going to take, instead of it taking 2 pi to complete one circle around, it's just like it's going faster. So now it's going to finish its cycle sooner. Okay? So now that means that I can't put 4 pi over here. I have to double this. So I have to take the 2 pi over 3 and then add another 2 pi over 3, which would then be 4 pi over 3. Alrighty? And then this is where things start getting crazy, because now if that changed, then the values that I had here are no longer pi over 2, pi, 3 pi over 2, as they have been for a while. And so you're probably freaking out, but you don't need to do so. I'm going to show you there's a really quick trick on how to find what these values should be. And so what you do is you take your period, which we know is 2 pi over 3. So I call this my increment. So these are like my little increments, right? So I want to know what my increment is. So I basically take my period, which is 2 pi over 3, and divide it by 4 because there's 4 equal increments. And that's always going to be the case. There are always going to be 4 equal increments. So that means that that's the same thing as taking 2 pi over 3 and timesing it by 1/4. So then you end up with 2 pi over 12, which is basically pi over 6. So now I know that my increment is going to be pi over 6. So this value right here is now pi over 6, not pi over 2. All right? And then I go counting from there. So this is 1 pi over 6. The next one would be 2 pi over 6, which is pi over 3. And then it would be 3 pi over 6, which is pi over 2. and then it would be 4 pi over 6, which is 2 pi over 3, then it would be 5 pi over 6, then it would be 6 pi over 6, but what is 6 pi over 6? 6 pi over 6 is just pi, and then 7 pi over 6, and then lastly would be 8 pi over 6, which is 4 pi over 3. So I hope that made sense, because I got to tell you that as far as me grading, I don't know if you've noticed yet, but all of these graphs look pretty much the same, but they have different numbers here and there. So when I'm graphing, when I'm checking your graphs, I have to check that all of these numbers are correct. If you don't have these correct, then you're not going to get full credit on the problem. So you have to have the right numbers there. So for cosine, it's a positive cosine, so we're starting at our normal, max, 0, min, 0, max situation. So I'm going to go ahead and put here at the top, this is my max, and then I go to 0, and then I go to my min. I hope that's lined up. And then I go to 0, go back to my max, and see what's happening is that normally it would take, this is pi right here. This is half of the normal period. So normally it would take twice this much to get one full cycle. And you're getting a full cycle at 2 pi over 3, which is before pi. So that's what I meant by saying that it's going to have a shorter period. It's going to complete its 2 cycles in a faster amount of time. So anywho, so then we're going to keep going. We're at our max. So then we go back to 0, go back to our min, go back to 0, and then back to the max. And so you get your graph that looks something like this. I apologize that I'm not trying to make them very pretty, but in the interest of time, there you go. So that is your part A, and so then you can see that the amplitude, the amplitude is 4 above, 4 below. This affected your period, so your start, your ending points are not 2 pi and 4 pi anymore. And so now we're going to do one more, and well, not one more, but we're going to do part B. So first we want to start with our amplitude. We know the absolute value of -2, which in this case would be 2. That tells me that I'm going to go between positive 2 and -2. There's again another B value, so my period is going to be 2 pi divided by 1/2, which is the same thing as 2 pi times 2, times the reciprocal of 1/2, right? Which is 4 pi. So my period is 4 pi. So this is like the opposite of what happened in part A. In part A, you shrunk the period, like you completed your cycle sooner. Now it's taking me longer. It's taking me twice as long. Normally it would take me 2 pi just to finish one cycle. Now I'm only finishing one cycle in 4 pi. So now it's slowing it down. So the negative is going to make it go upside down, but there's no phase shift and there's no vertical shift. So now we're going to go to our graph situation here. I'm just going to graph this stuff. I hope that now that we've done several of these that you're starting to see a pattern going on and that it makes sense. I really hope that it makes sense because I'm not going to be here to help you work through some of that stuff, but there you go. So now we're going to do our same thing we did last time. So see now instead of, I'm going to go all the way over here so I can get 2 cycles in, but if one cycle is 4 pi, then 2 cycles is going to be 8 pi. So if I put 8 pi there, I'm going to go in the middle here and put 4 pi. And then I'm going to cut this little guy. And this was actually kind of easy, but I still want to show that our formula works from earlier. We have to figure out what the numbers are going to be, which in this case is actually seems kind of easy. But just in case you're not sure, we always take our period. So for the increment, you're going to take your period, which is 4 pi, and divide it by 4 equal parts, which in this case is just pi. So it's easy. Pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. As far as our y-axis, we're going to oscillate between 2 and -2. So 2 and -2. And then we're going to go ahead and do our sine curve, remembering that that for sine we go 0, max, 0, min, 0. But remember that because it's a negative sign, we're actually going to go 0, min, 0, max, 0. Okay? So because we're going to do it, and so normally if your sine curve gave you a positive value, you times it by a negative, and it'll make it a negative value. So obviously if it's 0, 0 times a negative is still 0. So you're still going to start at 0, 0 here. But normally with the sine curve, you would go up to the max. But this time, because it's negative, you're going to go down to the min. And then back to 0. And then to your max. And then back to 0. And that's one cycle. And then you're going to go back to your min here. 0, max, and 0. So you're going to have your curve like that. So you can see how it did one cycle, bam, one cycle, repeat, and there you go. So that's going to be what you need for example 3, and then I'm going to do example 4. But example 4 and 5 don't have A and B, so they should go by a little bit faster. I'm going to do a really quick check of my time here. I really don't want to make this into 2 videos. Hopefully I won't have to. I still have some time. I have about 16 minutes or so before this video times out. So let's see if I can do that. Luckily for you, you can watch it over and over again if I go through something a little too quickly. I just want to make sure that I don't have you watching like 5 videos today. Okay, so please try to understand my dilemma. Here's example 4, find the amplitude, period, and phase shift. So this one has everything in it. It has a B, it has a C, actually it doesn't have a D in it. It has a B, it has a C, it has an A. So we're going to do the whole shebang bang here. So here we go. This means that it's not going to start at 0. So the amplitude is the absolute value of 3, which is still 3. For my period, it's going to be 2 pi divided by my B value, which is 2. So I'm going to get a period of pi. As far as my increments, that's still the case where you take your period and you divide it by 4. So my increments are going to be pi over 4. Every single time I move, I'm going to be pi over 4, pi over 4, pi over 4. And then my last thing is my phase shift, because that's, so my left endpoint, like where am I starting? My left endpoint is, this is the first time where we're not starting at 0. You take x minus pi over 4, and you make it equal 0. And you're going to add pi over 4 to the other side. So this time we are starting at pi over 4. We're not starting at 0. That's the biggest difference that I need you guys to understand in this one. So other than that, which is pretty much a big, difference, it kind of complicates the x-axis for us a little bit, but not too much yet. The last example will probably be the one that will complicate it the most. So, all right, so we're starting at pi over 4. And so let's just go with the y-axis first this time. And because my amplitude is 3, it means I have no vertical shift, so I'm still starting at my middle, but I'm going 1, 2, 3, and then I'm going 1, 2, 3, and then I'm not starting at 0. That's the biggest thing, is I'm not starting here. I'm starting at roughly pi over 4 there. So now when I go all the way over here, I cannot, I don't want to go like the middle from here to here. I want to go from the middle at pi over 4 to here. So the middle of that is going to be about here, and then I've got my little increments in here. And that's the issue, okay? That's the issue we have to deal with. So where am I going to end? So to get the next endpoint, so this is like, we haven't done that yet, but this is the first time we have to do that. We have our left endpoint. We're not starting at 0, we're starting at pi over 4. So I'm not going to end at pi because my period is pi. I have to add pi to where I started because that's where my period is, okay? So I'm going to take my pi over 4 and I'm going to add pi to that to figure out where I'm going to end up, all right? So that's actually 4 pi over 4, which is now 5 pi over 4. And so that tells me that this is 1, 2, 3, 4, 5 pi over 4 is right here. Okay? And that makes sense because that's 1, 2, 3, 4, 5. And then we're going to add another period to that because I need 2 cycles. So we're going to add 4 pi over 4 to that. And that's going to give me 9 pi over 4. And that tells me that this little value here is 9 pi over 4. So I hope that makes sense on how I did that. And then we have our increment is pi over 4. That means that each one of these little tick marks represents pi over 4. So we can go ahead and fill in the rest. This is 1 pi over 4. This would be 2 pi over 4. Oops, don't want the eraser. So 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4, which is just pi. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. Let's see if I can write my 4s correctly. I was doing so good. And then 8 pi over 4, which is 2 pi. And then 9 pi over 4. All right? So that's how that happens. And now we can continue like we used to, or like how we have been. So just remember that you're not starting at 0. So this is a sine curve. It's not negative. Sine starts at 0 and then goes up to its max, which is 3, and then goes back to 0, and then goes down to its min. I think that's 3. Then goes, I don't know why it's not letting me. Then it goes back up to 0, back up to its max, and then back to 0, and then back to its min, and then back to 0. So your curve is going to look something like this. Alrighty. And so you can see that it starts at pi over 4. Now technically it can keep going this way. Okay, but technically it starts right here. And so you get this little bit of a phase shift going on. So that is example 4. And then example 5 is the last example in the textbook. But I did want to do 2 examples that are kind of like the ones in your homework. So I hope, like I said, that I don't have to go into a 3rd video. But if I do, I will. And if you don't watch it, well, that's up to you. I just want to make sure that I give you all of the information that I possibly can so that you can do your homework well and then do the quiz well. Okay, so here's example 5. Again, has a little bit of everything. It doesn't have the plus D going on, but this probably was a little bit weird to you. There's a couple of ways that you can take care of that, but it's not a big deal. It's not going to make anything much different. So we're going to come over here so that I have some space. A equals the absolute value of 3/4, which is just 3/4. My period is 2 pi over b. And there's a couple of ways that you can take care of that little guy. Not that you need to, but the b value is still 2 because you could factor the 2 out if you don't like the way that looks. And you could go 2 times pi over 6, I think is what it would be, or pi over 3. So it would be plus pi over 3, I guess. If you did that, you could distribute, you go 2 times x is 2x, 2 times pi over 3 is 2 pi over 3. So if you wanted to look like the other ones have looked, this is fine, but you don't have to do that. It doesn't affect the fact that b is still 2. So you're going to go 2 pi over b, which is 2 in this case, and you get that your period is pi. And then your phase shift, you can take your x plus pi over 3 equal to 0, and now you're going to start at negative pi over 3. So last time we started at positive pi over 4, this time we're starting at negative pi over 3. And remember that even if I hadn't factored it, I still could have done 2x plus 2 pi over 3 equal to 0, and I still would have gotten the same answer. So it doesn't matter that I factored it, just so that you don't have to factor it if you don't want to. Anywho, so then that takes care of all that stuff. I need my increments. So my increments, what are going to be my values? Because now it's going to be all weird. My increment, if you recall, is to take your period and divide it by 4. My period was pi, so dividing it by 4. All right, and that's where things start getting crazy for this function. Just want to check my time, make sure that I don't start this and then it's going to die on me. I've got about 5 minutes. I think I can do this in 5 minutes. So here we go. Gonna draw this little sucker. I do think that I'm gonna have to go into a third video for the other 2 examples, but it'll just be examples, so that'll be up to you if you want to watch it or not. There's a couple of homework questions that might throw you off, and so I just wanted you to, maybe you can just do the homework, and if it doesn't throw you off, then don't watch it, and if it does throw you off, then you can watch it. You can go back and see kind of how I did it. So my MOLO, I shouldn't have put that y-axis there yet, because now I know that I'm starting at negative pi over 3. All right, and so the problem here is that I'm not starting at 0, I'm starting at negative pi over 3, and I'm going to end over here somewhere. And remember that we did earlier, to figure out where I'm going to end, I have to take where I started from. So my left endpoint, I know, is going to be negative pi over 3, left endpoint. But my right endpoint is going to be for me to take where I'm starting and adding the period to that. And my period is pi, which is basically 3 pi over 3. So when I do that, I'm going to end up at 2 pi over 3. And then, so I know that the middle between here and there is going to be 2 pi over 3. And then if I add another 3 pi over 3, because I want 2 periods, remember, I'm going to end up at 5 pi over 3. Now, I'm starting to look at that and think, is that not quite the middle? I really hope it's the middle. And then I'm going to end up at 5 pi over 3. But the problem is now that when I do my increments, I'm going to need to be here, 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 and here, here, here. Where does the y-axis go? So that's kind of the problem right now. So I'm going to show you guys a quick way of how to do this. I know that it's going to frustrate some of you. So I'm going to go to the calculator screen real quick. Or I'm going to try to. There it is. And I'm just going to show you how you can take, we know that we were starting at negative 1/3. And our period is pi. So if I add 1 to that, no, I'm sorry, our increments are pi over 4. So I'm going to add 1/4 to that. And I'm going to get this crazy fraction, negative 1/12. That means that let's see if I can. That means that this number right here is negative pi over 12. So you can probably see why I didn't put the y-axis right there, because I don't know where it goes. The y-axis needs to be the middle, like the 0, like there's negatives on this side, positives on that side. So I need to put these numbers down before I start figuring out what that's going to be. So I just wanted you to know that you can, if you can't figure out what these numbers are, you can do it on the calculator, which is what I was doing back there. So I don't want to keep going back to that screen. I think I showed you what's going to happen. I'm going to keep doing it, but I'm just going to do it on my calculator here. And I'm going to take, I'm now at negative 1/12. And remember, my increment is pi over 4. You don't want to put pi in the calculator because it's going to give you a weird decimal you can't fraction. So I'm going to take the 1/4, and I'm going to take my negative 1/12, and I'm going to add 1/4 to that, which gives me 1/6, which means this is pi over 6. So now that means that my y-axis needs to be somewhere between here and here, because this is negative and positive. Now, obviously, this is smaller than that, which means that the y-axis should be closer to the pile